Okay, so this was the last problem that we solved yesterday, right? We were discussing the dimensional analysis. Now let us solve some more problems based upon dimensional analysis. So let's see this one. The if C be the capacitance and V be the electric potential, then the dimensional formula for CV square is, dimensional formula of CV square is. Who can tell me? Anyone? Okay, so now again here we need to know the formulae, right? So if we know this formula, that potential energy of a capacitor is given by half CV square. Okay, then immediately we know that dimensions of CV square are same as that of dimensions of energy, right? So what are dimensions of energy? M1 L2 T minus 2. These are the dimensions. That's it. So which one is correct? M1 L2 T minus 2, and A will be equal to 0, right? M1 L2 T minus 2. So it is option A only. This is clear? Okay, good. Let's see next one. If E and G respectively denote energy and gravitational constant, then E by G has dimensions of. So here of course we need to know the dimensions of energy, and then you have gravitational constant. Okay, so if you know the dimensions of gravitational constant, it will be very easy to solve, right? If you remember all of the dimensions as we discussed yesterday, okay, it will be very easy to solve. Otherwise what can we do? Still this thing can be done faster. So E is energy. Energy can be written as what? You can write it as force into displacement. Okay, work done is equal to energy, you can say. It can be written as force into displacement. And you have formula for gravitational constant. The gravitational force is given by G into m1 m2 by r square. Yeah, so what you can do is G can be written as fr square by m1 m2. So what is m1 m2? You can say m square. So you just divide this thing by this thing. Okay, so let's divide this thing by this thing. So what do we get? We want E by G, no? So f r and the square gets cancelled. This m square goes to the numerator. That means it is m to the power 2 in the numerator, and in denominator you have r. That's it. Okay, so it is m to the power 2 in numerator. In denominator you have distance. Distance means length to the power 1. If you take it to the numerator, it becomes m2 l raised to minus 1. Okay, so that's the answer. It is option B, right? Very, very simple. Okay, this one is clear?
Yes, sir.
Good. Alright, then let's see next one. If force, acceleration and time are chosen as fundamental physical quantities, find the dimensions of energy. This is the question. So once again, now see, you have the formula connecting energy and force, right? Okay, so ideally what you have to do is, energy depends on force. Okay, it depends on acceleration. Acceleration is, they are writing it as capital A. Then time, so it is f to the power a to the power b, time to the power c, right? And we know that this is a time consuming process. Okay, then we remove the proportionality sign, or directly we write energy is equal to some number, some constant, times f raised to a raised to b, and t raised to c, and then we find out abc. So this is a time consuming process, we will not go into that, right? So what we will do is, we know this formula, we want relation of energy with force, a is acceleration and time. So what we will do is, we know this energy is equal to force multiplied by displacement, right? Force into displacement. Let's write d for displacement. Okay, so f is already there in this formula. That means we need to represent d in terms of acceleration and time. So what is acceleration? Acceleration is, what are dimensions? L1 t raised to minus 2, and out of that you want only L1, right? Out of that we want only L1, so we need to get rid of this t raised to minus 2. So how can we do that? So if we multiply a times t raised to 2, okay, they are writing it as capital T only. So if we do a times t raised to 2, then it will be equal to, its dimensions will be equal to L1 t to the power minus 2 t to the power plus 2. So this thing gets cancelled, right? And we get L raised to 1. That's what we wanted. So energy becomes F multiplied by A t to the power 2. This is our answer. Okay, so what is the value of A, B, C? A is 1, B is also 1, and C is 2, right? So this is the answer, F1 A1 t to the power 2. Okay, that's option C. Yeah, good. So this is clear. I'm sorry. Okay, it's very good. So we should use this kind of simple process. Okay, we shouldn't do this thing because it is time consuming. Okay, we should avoid it as much as possible. All right, let's see next one. This is good question. Okay, let's check the years here. This was from 2021. This is also from 2021. Okay, this is from 2020. Dimensions of stress are. So we know what is stress. Anybody we saw yesterday? Force by area, right? So what are the dimensions? Dimensions of force divided by dimensions of area. So it is L1 m1 t minus 2 divided by dimensions of area, right? This force is stress is what? Force by area. So area is L to the power 2. Take this thing will get cancelled out, right? There will be L raised to 1 in the denominator. Take it to the numerator, it becomes L raised to minus 1. So that is L to the power minus 1, m to the power 1, and t to the power minus 2. So m1 L minus 1 t minus 2, option C. This is the answer, right? Very good, Pawarna and Diveshwani. Okay, so this is very simple, right? Okay, then let's see next one. If force, velocity and time are taken as fundamental units, is it repeated? Then dimensions of mass are, that was force, velocity, no, it wasn't even velocity. Okay, if force, velocity and time are taken as fundamental units, then dimensions of mass are. Tell me, what will you do? Force, velocity and time. So force, you want mass, no, mass in terms of force, velocity and time. Okay, there will be some A, B, C, right? So force can be written as what? Force can be written as, okay, it's option D, F v to the power minus 1 t. Let's check. Who said this? Yamini? Who was that? Yamini, Indusha? Okay, somebody said option D. Let's check. Alright, so force can be written as what? It is mass into acceleration, right? And you just want mass. On left hand side you have mass only, and force is mass into acceleration, and acceleration can be written as what? V by t. Okay, so this is just force. Okay, I am writing for force only. So this thing is equal to m into v by t, and you need to get rid of this v and t. So what should you do? You should divide by v and multiply by t. That's it. Okay, so this thing is force, and you are dividing by v, multiplying by t. Okay, so force by v times t. This should be the answer. Yeah, so it is option D. Very good. Okay, somebody said option D. Alright, let's see next one. Planck's constant h, speed of light in vacuum c, and Newton's gravitational constant g are three fundamental constants. Okay, so Planck's constant h, and then Newton's gravitational constant g, and speed of light in vacuum c. Which of the following combinations has which of the following combinations of these has the dimensions of length? So you need to represent these things. L in terms of h, okay, h to the power a something, c to the power b, and g to the power c. Now if we try to do this, it will take very long time. So what we should do is we can write g as we know, fr square divided by m square, right? G can be written as fr square by m square. But do we have f here? We don't have f. So that means what we can do is, there is c is the velocity, right? So we can represent this thing in terms of velocity. So what I will do is, it is fr into r, and what is fr? It's energy. Force into displacement is energy, okay, divided by m square, and therefore energy is equal to, I want to write energy in terms of velocity. So it can be written as half mv square, okay. Then I have r, and in denominator I have m square. Then I don't need half, okay. See, why did I write half mv square? Because I have c here. C is speed, okay. So I want to write this fr in terms of speed, okay. So this m gets cancelled out with the square. So you can say g is equal to v square r by m, okay. Similarly, now Planck's constant has same dimensions as that of angular momentum. This thing you have to remember, Planck's constant and angular momentum. They sometimes ask this question also. Planck's constant has same dimensions as that of, okay. So it is angular momentum, right? So h has same dimensions as that of angular momentum, that is mvr, okay. Angular momentum has dimensions of mvr. It's option A. Let's check. And then you want to find out length in terms of this. So L is h is mvr, okay. I will just say mvr. Then I want length only, right? So I need to get rid of this v. So then I have v square r by m, and I also want to cancel out m, right? I also want to cancel out m. So what I will do is mvr, I will multiply with this thing, v square r by m. I don't have any problem with r because it will just add it up, its square will be there, okay. So then we can just take square root if we want. So here this m gets cancelled out, and you have c, okay. So here I have v cube, which I don't want, that's why I will divide by c cube, okay. So this v cube and c cube, dimensionally it will get cancelled out, and then I have r to the power 2, okay, and whose square root I will take, right? So the answer will be, what is mvr? It is h. What is this thing, v square r by m? It is g, and then I have c cube, so it will be square root of that. This is the answer, right? So it is option A, right? It's option A. This thing is clear? Yes, no? Everyone? Okay. So I guess still we managed to solve it within 1 minute, okay. And I explained and solved, right? So it takes little bit longer time, but if we solve this way, it takes lot of long time actually, okay. So good. Then let's see next one. Again there is, okay, e square by 4 pi epsilon naught. This is from NEET 2017. This is from 2016. All right. A physical quantity of dimension of length that can be formed of c, g and e square by 4 pi epsilon naught, okay. C, g and e square by 4 pi epsilon naught. So now where does this e square by 4 pi epsilon naught come? It comes in the Coulomb's law. Coulomb's law can be written as 1 upon 4 pi epsilon naught e square by r square, okay. So you have e square by 4 pi epsilon naught r square. That means E square by 4 pi epsilon naught can be written as what? It can be written as FR square. Okay, and G can also be written as FR square by M square, right? G can be written as FR square by M square. And you have again speed of light, and you want the length again. Okay, you want length again. So what can you do here? So this FR square, we can get rid of FR square and FR square, but is that sufficient? No, we want length only, right? So again what we can do is we can write that FR square, as we did in last problem. This thing can be written as, okay, because we have speed of light, we need to get rid of speed and mass. Okay, there is no problem with length. So FR, 1 FR, F times R is energy. It can be written as half mv square. Let's write mv square times R. Okay, so this thing is mv square times R, and this thing is what? Again 1 FR can be written as mv square. Okay, so this is mv square by R, sorry, mv square times R divided by m square. Okay, and this m gets cancelled out with this square. Okay, and therefore you have v square R by m. Why did we do this? If we wanted to cancel out FR square, we could cancel out by dividing these two. Okay, but we want to cancel out velocity, right? So once again, if you multiply these two, I guess if you multiply this and this, then what will happen? You will have, no, we can't multiply, no? Yeah, we can. If we multiply these two, then m and this divided by m, it will get cancelled out. Okay, so I will multiply E square by 4 pi epsilon naught multiplied by G. So what happens is you have mv square R multiplied by v square R divided by m. Okay, so first I am cancelling m. I am not caring about the velocity because I have velocity c. I have anytime I can divide by any power of velocity, right? I can get rid of that. That's why first I am getting rid of m. I'm getting rid of m. Okay, so m gets cancelled out, and then you have v square, that is v to the power 4. You have r square. Okay, so this is equal to v to the power 4 r square. That means now what do you want? You want length only, you want r only. So you will just divide by c to the power 4. So just divide this thing by c to the power 4. So this v to the power 4, c to the power 4 gets cancelled out, and you can take square root of this r square. So the answer is this thing, right? So it will be just r, or length you can say. So it is square root of E square by 4 pi epsilon naught G. It's there in option A, it's there in option, and in denominator you will have c square. Okay, so it's option D, right? This is clear. Yeah, everyone? Okay, good. So we need to employ these kind of small tricks. Okay. All right, let's see next one. Which two of the following 5 physical parameters have same dimensions? Tell me if you know. Energy density, then refractive index doesn't have any dimensions, dielectric constant, then Young's modulus, and magnetic field. Tell me. Okay, let's see energy density. What is energy density? It is energy per unit volume. Okay, that is energy per unit volume. V is volume, okay, not velocity. So it is m1 L2 T minus 2 divided by volume. Volume is what? L3. So what will be the dimensions? m1 L minus 1 T minus 2, right? L to the power 2 minus 3 is minus 1. Then you have Young's modulus. Okay, what are Young's modulus? Young's modulus is force by area. So force by area, so you take force is m1 l1 t to the power minus 2 divided by area. So the area is l to the power 2. Take it to the numerator, it becomes minus l1 minus 2. So that is m1 l minus 1 t minus 2. Yeah, it matched, no? Then we don't need to find out dimensions of magnetic field, etc. I also don't remember. Okay, I'll need to use some formula. Anyways, so it is 1 and 3. It's not 3, no, it is 4. 1 and 4. It's option A. This is clear. Okay, good. So now you tell me the pair of quantities having same dimensions is. Yeah, good, Divashivani. Tell me impulse and surface tension. Do you know what is impulse, what is surface tension? What is impulse? Impulse
Instantaneous force.
Impulse is force multiplied by time. Okay, impulse is force times time. Anyways, surface tension is force per unit length. Okay, surface tension is force per unit length. Let's write S for surface tension. Okay, it is option C. Let's check. Yeah, that's correct. So surface tension is force per unit length. So obviously they don't match. Diveshwan is saying it's option C. Let's check whether it's correct. Work done is force into displacement, and torque is perpendicular distance multiplied by force. Okay, so yes, dimensionally they are same. That is correct. Very good. Okay, this was very simple question. If we know formally, it's very simple. If we don't know, it's very difficult. Right? We can't do anything. All right. All right, let's see next one. The dimensions of mu naught epsilon naught to the power minus half r. Okay, maybe you don't know the formula for this. The speed of light is given by 1 by square root of mu naught epsilon naught, but the problem is it will come in electromagnetic waves. Okay, yeah, so it is L1 t raised to minus 1 and raised to half also. Okay, so that is option A only. Right, this is clear. Okay, so it is just speed mu naught epsilon naught. It is square root of mu naught epsilon naught, right? But it's 1 upon square root of mu naught epsilon naught. Okay, so that means it is mu naught epsilon naught to the power minus half, this thing. Okay, that's why this is the answer. Right, let's see next one. The dimensions of half of epsilon naught E square, where epsilon naught is permittivity of free space and E is the electric field, is. Tell me, anyone? This is also energy density. Okay, if you find out energy per unit volume of a conductor, okay, which is being charged, or a capacitor which is being charged, then it comes out to be equal to, this is energy per unit volume, U by V. U is energy and V is volume. So this is also a direct formula. Okay, so energy is L1 sorry m1 L2 t minus 2 and volume is L cube, so it is m1 L minus 1 and t minus 2, m1 L minus 1 t minus 2, right? It's option B. Very simple. Okay, let's see next one. It's the same one, I guess. Okay, so that's the end of the problems. Okay, so let's begin with errors. Now what is an error? So you perform any measurement. If the measured value is greater than or less than the true value of any quantity, then you have done some error, right? So error is the difference between the true value and the measured value of a physical quantity, right? It's the difference between true value and the measured value of a physical quantity. And there are these two types of errors: systematic errors and random errors. Okay, so what are systematic errors? The errors that take place in the same direction always, they are known as systematic errors. Okay, so what does it mean? If it is positive for the first time, in second measurement also it will be positive, in third measurement also it will be positive, it will keep on coming positive, right, in all measurements. That kind of error is known as systematic error. You are doing error systematically. Okay, so that is one type. Second one is random errors. Random errors, sometimes they can be positive, sometimes they can be negative. Okay, so in sign they can change. Sometimes the measured value is greater than the original value, sometimes it can be less than the original value. This is one form in which random errors can happen. And also they can change in magnitude, right? They can change in magnitude also. Like suppose you want to measure my height. Okay, so if you measure my height in centimeters, suppose for an example, suppose it is 142 centimeters, something like that. Okay, don't take it literally, I have not calculated. So suppose somebody measures it and he or she finds that the height is 143 centimeters. Somebody says it's 150 centimeters. Okay, so that is too much change in magnitude, right? But it will not come in the random error. It is systematic error only because it is performed by some person. What is the random error? So for an example, suppose you are doing some experiment. For an example, you are measuring resistance of a wire. Okay, so you know the Ohm's law, V is equal to R into I, right? You want to measure resistance of a wire. Then what happens? There are certain fluctuations in the voltage, okay, because of which the current will change, right? Suppose there are some fluctuations in voltage. You have applied some voltage and according to you that voltage, the applied voltage is constant, right? So you are taking some value of voltage and suppose all of a sudden there is some fluctuation. Okay, so then what will happen? The current will change and you will not know that there is change in voltage. So this is happening randomly. Okay, it's not in your hand, right? Or you can take another example. For an example, you are measuring speed of a pendulum, not speed, time period of a pendulum, and some wind is blowing in, sometimes it is blowing in this direction, then it is blowing in this direction. Okay, so what will happen? It will change the time period, right? So there is formula for time period. Okay, so it is 2 pi square root of L by G, and because of wind there will be extra acceleration. Okay, and that is, you might know that there is a wind, but you don't have any apparatus to measure the force exerted by wind, etc. So there will be some small error in the measurement of time period, right? Okay, so that is random, that is act of God, right? Natural calamity, you can't do anything regarding that. But systematic errors can be minimized, okay, or they can be corrected. How? So systematic errors are majorly or of these two types. One is instrumental error, one is personal error. So what is an instrumental error? Error in an instrument. Okay, so for an example, For an example, zero error. Okay, so what is a zero error? So suppose you want to measure current in some circuit, okay, and your ammeter, when there is no current flowing in the circuit also, it shows 1 milliampere. Then what will be the value when there is actually 5 milliamperes of current flowing in the circuit? What will be the value shown by the ammeter? It will show 6 milliamperes. When it is 10 milliamperes actual current flowing in the circuit, it will show what? 11 milliamperes, right? Very good, it will show 11. So each time it is showing 1 milliampere extra. So this kind of error is known as zero error. This kind of error is known as what? Zero error. So what should you do? You should subtract this zero error from all of the readings, okay, all of the measurements, to get the actual measurement, right? So this can be minimized, and it is systematic. That means for the first time, I mean when there is no current flowing in the circuit, it shows positive error. Every time it will show positive error only, and magnitude wise also it will be same. Okay, so this is clear why this is systematic. Okay, then there is personal error. So what is a personal error? So personal error, for an example, you want to measure a length of a desk. Okay, you want to measure length of a desk, and you have some scale, and suppose you put left end of the scale at left end of the desk, and then you stretch your scale. Okay, the rolling scale is there, no, you stretch that, okay, till the another end, and you see like this. Okay, what's the length? Let me check. Okay, or some, this is the habit, right? Some people they will see like this, some people they will see like this from this side. Okay, so this is not correct way to measure the length, right? So for these people who are seeing from the left side, for them the reading will be little bit more. For the people who are seeing from right hand side, reading will be little bit less. You have to see at right angles. Okay, so this is an example of personal error, right? So the person doesn't know how to take reading, so the person has to be taught that you have to look at right angles to the scale, right? So this is a personal error. Okay, all right. So this is habit, this might be habit of a person also. Okay, so they have to be taught. And once again, now there might be somebody like, okay, there may be somebody who sees once from this side, okay, at the second time from this side, right? So you can't do anything about them, right? But most of the people, they will have habit of seeing from left, or either from left or from right. So for them it can be corrected, right? And for them each time the error will happen. If it is positive, each time it will be positive. If it is negative, each time it will be negative. This is clear? Yes, no? That's why it is systematic error. This is clear? Okay, everyone? Good. So then next, let's discuss accuracy and precision. What is the accuracy? So in normal English, in our day-to-day language, accuracy and precision, they are the same thing, but in physics or in measurement they are different. What is an accuracy? Okay, accuracy is the closeness between the true value and measured value of a quantity. Okay, closeness between the true value and measured value of a quantity, right? So the measure of how close the measured value is to the true value of a quantity, that's accuracy. And what is a precision? Precision is to what resolution the quantity is measured. For an example, suppose true value of length is 15.71 centimeter. It's given to you. Okay, suppose you measure length of this pen and somebody tells you that it is 15.71 centimeter, or it is written on the specifications, okay, right, in the box of this pen, okay, it's 15.71 centimeters, it's written, that is true value. Now you take three different measurements, somebody measures it with some instrument and he says that it's 15.7 centimeters, okay, then somebody measures using some other instrument, he says that no, it's 15.65 centimeters, and somebody measures with some another instrument, he says that no, it's 15.565 centimeters. So which of these is correct, which of these is more accurate? Tell me, which is closest one? Yeah,
L3.
right, L1 is closest, right, this is closest, no, there is only 0.1 difference here, right, so here also there will be 0.6 difference in L2, so L1 is closest, 1 is closest, right, but then what is the precision? So precision is the resolution, resolution means after decimal points how many digits are there, okay, so see these instruments are different, they are not same instrument. First instrument can take reading up to what, 0.1 centimeter, that's its minimum reading, okay, minimum reading is called as least count, so that's your normal scale, okay, your normal scale has reading in millimeters, no, okay, 1 millimeter, 2 millimeter, 3 millimeter, right, yes, no, 10 mm is 1 centimeter, so this is your normal scale, okay, then you might have seen there are other scales which is known as vernier scale, okay, so vernier scale gives the reading which is more resolved means in more detail compared to the normal scale, right, then there is screw gauge, but now you won't measure the length of the pen with screw gauge, you can't measure that, but suppose there is some other instrument which gives you even more detailed reading, right, so this is more precise, this is with more precision, precision tells you what, the resolution of an instrument, this instrument can take reading up to what, its minimum reading is 0.1 centimeter only, the minimum reading of this one is 0.01 centimeter only, so this is more resolved, okay, this is more resolved, this one is for minimum reading, minimum reading for this one is 0.001 centimeter, so it is even more resolved, okay, and generally the more resolved is the instrument, more accurate reading you will get, but here in these values this one is more accurate, okay, and this one is more precise, this one is more accurate, this one is more precise, this thing is clear everyone,
Clear, sir.
right, okay, in physics the accuracy and precision are different things, but generally you have better instrument, more precise instrument, and you know the correct technique, then your reading will be more accurate also, okay, so this thing doesn't mean you shouldn't have a better instrument, right, any doubt in this, Indusha, anybody?
No, sir. Clear.
Okay, good. So this is accuracy and precision, these are some definitions regarding error. Now let's move on to the measurement of errors, how to measure the errors. So let's see what is an absolute error, relative error, and percentage error. Suppose you want to measure some quantity, let's again consider the length of this pen, okay, and it is given to n number of people, n number of students suppose in this class, and they measure lengths L1, L2, okay, up to Ln, these are the measurements, and suppose I don't know what is the true value, then what I will do is I will find out the mean of all these readings, okay, so length measured by Indusha, length measured by Selva Kumar, okay, that's L1, L2, so on and so forth up to Ln is suppose length measured by Nikita, and I will add it up and divide by n, so this is the mean value, right, this is how we take mean, mean means average, this is the average value, right, so now we'll consider this mean value as the true value of this quantity. Okay, we'll say that this is the true value of the quantity. So what will be error in the first measurement? So error in first measurement is, suppose delta L1, it is L1 minus this mean value. Error in the second one is delta L2, it is L2 minus Lm, so on and so forth. Error in the nth measurement will be equal to Ln minus Lm, right? So this is how we find out the errors. But now sometimes the error might be positive, sometimes they might be negative. Okay, and it might happen that suppose you want to find out the average of these errors. Okay, so if you add, suppose for an example, L1 is delta L1 is 0.1 centimeter and delta L2 is minus 0.1 centimeter, then L3 is delta L3 is minus 0.2 centimeter. Okay, and some other reading is plus 0.2 centimeter, and you want to find out the average error. If you add it up and divide by n, what will happen? There are chances that it will come out to be equal to 0, right? But does that mean that on an average you are performing 0 error? No, right? So what we do is we take absolute value of the error. Okay, sometimes the error will be positive, sometimes the error is negative, and we are not biased. Positive error is also error, negative error is also error. What we do is we take absolute value of the error, right? So absolute error is represented like this. This is the absolute value symbol, right? You know that. Okay, so in nth measurement, in any measurement, in L1, suppose the absolute error would be like this. Okay, it will be represented by this absolute value symbol, 2 lines. Okay, what does that mean? Even if the error is negative, suppose delta L1 is minus 0.1, still the answer of this thing would be what? It's 0.1. Okay, so we get rid of the negative sign. Then we find out the mean absolute error. What will be the mean absolute error? Just take absolute errors in all quantities. Okay, sorry, in all measurements. Quantity is same, measurements are different. Just take absolute errors in all measurements, add it up. Okay, and divide by number of measurements. Okay, divide by number of measurements. So you get the mean absolute errors, mean absolute error. Okay, so this is the mean absolute error. So now the chances are that the measured value of your quantity will be plus minus measured value will be in between Lm minus delta Lm, okay, and Lm plus delta Lm, right? The measured value is, suppose L, it might lie in between what? Lm, the mean value of quantity, minus the mean error, and the mean value of quantity plus the mean error. This thing is clear? Yes, no? Okay, unless you are taking very biased measurement, right? Okay, so the measured value of a quantity generally lies between Lm minus delta Lm and Lm plus delta Lm. Alright, so this is the mean absolute error. The next is the relative error. So just take mean absolute error, divide it by the mean value of a quantity, you get the relative error. Okay, so mean absolute error in length is delta Lm, mean value of length is Lm. So delta Lm divided by Lm is the relative error. Very simple. The next is the percentage error. Just multiply relative error by 100 and you get the percentage error. Okay, that is percentage error. So any confusion in these definitions?
No, sir.
Okay, everybody? Good. Let's see after that. So these are error in one measurement. One measurement means not one measurement, error in the measurement of one quantity, right? Now suppose you want to measure two quantities, okay, and you want to find out error in the combination of those two quantities, right? So because sometimes you need to add quantities, sometimes you need to subtract, sometimes you need to multiply, okay. I'm sorry. For an example, you want to find out perimeter of a rectangle. So do you know what is the perimeter of a rectangle? Suppose this is a rectangle, you want to find out perimeter. So perimeter is total area of the boundary, right? So this is length and breadth. So perimeter would be equal to what? It is 2 times of L plus B into 2. Very good. So it will be 2 times of L plus B. So you will measure length, you will measure breadth of the rectangle, and you will add it up and multiply by 2. That is the perimeter. Then another example is you want to find out semi perimeter. So semi perimeter is just half of the perimeter, it's L plus B. So here you need to add up the two quantities, right? You need to add up the length and the breadth. So for length you will take separate measurements, okay. For breadth you will take separate measurements, right? And then there might be n measurements for length, there might be n measurements for breadth. Then you will find out the true value of length, you will take mean of all those measurements, right? And you will find out mean absolute error, okay, in length. You will find out mean absolute error in breadth. So what will be the mean absolute error in the semi perimeter? That's the question. So this is like a common sense only. The mean absolute error will be added up because you are adding the two quantities. Okay, this thing is clear? Yes, no? Okay. So in case of addition and also in case of subtraction, what happens is the mean absolute error gets added up, okay. So suppose you can take C is equal to A plus B, right? A is one quantity and delta A is error in A. B is one quantity, another quantity, delta B is error in B. And suppose C is equal to A plus B, okay. So now see, measured values can be written like this. So A dash is the measured value of A, it will be A plus minus delta A. B dash is the measured value of B, it can be written as B plus minus delta B, okay. So what does this mean? This is the mean value of A and this is possible error plus or minus delta A, okay. This is the mean absolute error possibly, okay. So as we said, the value lies between what? The measured value of a quantity lies between mean value minus the mean error and mean value plus the mean error, okay. That's why we write it like this. So it is A plus minus the mean error, right? Then similarly measured value of B will be B plus minus delta B. Then suppose C is equal to A plus B, what would be the measured value of C? Let's call it C dash. C dash will be equal to A dash plus B dash. Then what you do is you write C dash as C plus minus delta C, and you put A dash is A plus minus delta A, B dash is B plus minus delta B. Then what you do is you just cancel out the C with A plus B, right, because that's what it is. C is equal to A plus B, and then you get plus minus delta C is equal to plus minus delta A plus minus delta B, okay. And therefore what is delta C? It is delta A plus delta B, right. So now there are various possibilities here. So you can take this plus sign, plus minus sign, minus plus sign, minus sign, right? But now we want to find out what is the maximum possible error in the resultant, and that's why we just add up the errors. We don't take negative signs, okay. Our aim is to find out how maximally our reading can be wrong? What is the maximum possible error? That's what we want to find out. That's why we take just positive sign. Okay, so this is error in the addition. In subtraction, what will happen? So there will be just a negative sign here. Again, the c will get cancelled out because c is a minus b. Here it will be, get cancelled out, and your answer will be plus minus delta a minus plus delta b if you subtract b from a. But still you will take what? Positive sign only, because you want to find out what is the maximum possible error. Okay, is that fine, everyone?
Yes.
Good. All right, so this is an example. As I said, perimeter is written like this, 2 times of L plus B. So what will be error in the measurement of perimeter? It will be 2 times of delta L plus delta B. Okay. All right, next, now we might need to multiply two quantities also sometimes, and we might need to divide them also. So in multiplication or division, what happens to the error? So for an example, the area of a rectangle is equal to what? The area is length times breadth. So there is some error in length, some error in breadth. What would be the error in area? Okay, so that's what we want to find out. So suppose c is equal to a times b. Okay, so therefore c dash, these are what? The absolute values. Okay, I mean the mean values of a and b, two quantities. So c is some other quantity. For an example, area is equal to what? Length times breadth, one quantity multiplied by second quantity. Then the measured value of that area or the resultant quantity would be what? Measured value of a multiplied by measured value of b. Very simple, right? So again we put c dash is equal to what? C plus minus delta c. A dash is equal to a plus minus delta a. B dash is equal to b plus minus delta b. Okay, then you expand this, so then these four terms will come. Out of that, first term will be a times b. So a times b is what? It is just equal to c. You cancel out that c with a times b. Then what do you get? Plus minus delta c is equal to plus minus of a delta b plus minus delta a times b plus minus delta a delta b. And out of these, this quantity would be very small, delta a times delta b. Okay, so if I want to tell you an example, suppose this is the length, this is the real length of the rectangle, and this much is the error. This is still very big error. Okay, suppose this is some error. This is the breadth, right, and this much is the error in breadth. So actual area would be this much, right? This much would be the actual area. Okay, and this is the extra area that you are measuring. Out of that, this is delta L. If you see this is delta L, right, and this thing is delta B. So what is delta L times delta B? It is just this small, this one, okay, this small rectangle. This is delta L times delta B, right? It's very small. This thing is clear? Okay, so that's why I'm saying that this delta A times delta B would be very small. Okay, then what we do is we divide this whole thing by A times B. Okay, so we get this plus minus delta C divided by AB, or you have C, AB is equal to C, right? And here also on right hand side you divide it by AB everywhere, and then this quantity which was already very small, now you are dividing by AB. AB is the area. Okay, so what you are dividing, you are dividing this thing by this whole area. Okay, so this thing was already very small, you are dividing it by this complete quantity. Okay, I mean this complete area, right? So that the division or this quotient, it would be very small. So we get rid of this, we just neglect this one. Okay, Then here a and a will get cancelled out, so you have plus minus delta b divided by b. Okay, and what is left in this term? So b and b gets cancelled out, so you have plus minus of a divided by a. So finally you get delta c by abc, so delta c by c. Okay, so this is the result, sorry, this is the relative error in the resultant. It is delta a by a and plus you have delta b by b. So if you multiply two quantities, then what happens is error in the resultant is what? Just relative error in the resultant is sum of relative errors in the two quantities. Okay, this is the result. Even if you have c equals to a by b, then also the relative error in the resultant, that is c, will be equal to relative error in a plus relative error in b. Okay, so this one I am not explaining, it's lengthy. Okay, but it's similar, right? So we just need to remember, in case of the multiplication or a division, what happens is relative errors are added up. This is clear, everyone?
Clear, sir.
Okay. Okay, good. Next, error of a power. Okay, suppose you know that if c is equal to a times b, then what happens to the relative error? It is delta a upon a plus delta a and delta b upon b. Now suppose c is equal to a square, so this is still, I can write this thing as a times a, right? I can write this thing as a times a. So what will be error in this one? Delta c by c will be equal to delta a by a. Okay, error, relative error in first quantity plus the relative error in second quantity, that is also delta a by a. So if c is equal to a square, then delta c by c will be equal to what? 2 times of delta a divided by a. This is clear? Yes, no? Okay, very good. So then if you have c equals to a cube, that is a times a times a, 3 times, right? You are 3 times multiplying a. Then what will be delta c by c? It will be 3 times of delta a by a, right? And if you have c equals to a raised to n, then you have delta c by c will be equal to n times of delta a by a. Very, very simple. Right? Very good. And then you have a general result like this. So suppose some quantity is a raised to q, b raised to x, c divided by c raised to y, d raised to z. Then what will be the relative error in this quantity? It is just, okay, delta p by p can be written as q times of, okay, q times of, because a is raised to q, okay, q times of delta a by a plus x times of delta b by b plus y times of delta c by c plus z times of delta d by d, right? Okay, very good. So these are the errors. Okay, and then let's see a small topic called as significant figures. So what are significant figures? So significant figures means, suppose you are taking some measurement, you are taking some reading. So in that reading, for an example, I measure length of this pen, okay, and I say that it is 15.71 centimeters. I am measuring it using the vernier caliper. Okay, then in this 15.71, I am very sure about these 3 digits, that it will be 15.7 something. This last digit, it might be +1 -1, right? There can be some error in this one. Okay, for an example, if I see from this side, I have calculated little bit extra. If I see from this side, I have calculated little bit less. Okay, or there might be a little bit of sliding of the scale also. By any possibility, there are numerous possibilities, right? So this one, the last digit, can be, it might not be correct, it might be correct also, it might not be correct. Okay, so this last digit is known as error digit or error bit, you can say error digit. Okay, so what are significant figures? So these four figures means in this reading there are four figures. So all the digits that you are certain about plus first uncertain digit. Okay, or all the figure means numbers, so all the numbers that you are certain about plus one uncertain number. Okay, that is known as the error digit. Okay, so these are significant, these are important. Okay, these are important. This thing is clear? Yes, no? Okay, good. So there are certain rules to find out the significant figures. So all the non-zero digits are significant. If there is a non-zero digit, it is significant, right? If you write a measurement, every non-zero digit is significant. All zeros between two non-zero digits are significant. For an example, in place of 15.71, I write 10.71 centimeters. Suppose this is the length of this pen. So this zero, which is in between two non-zero digits, is significant. Okay, or there are two zeros like this, 100, okay, 0.71, something like this. So this zero is also significant, this zero is also significant. Okay, so the zeros in between non-zero digits are significant, right? That's the second rule. Next rule is all zeros before the first non-zero digit are not at all significant. I can write 100 zeros before this first one or first non-zero digit, and all of them will be insignificant. They are not at all important, right? Okay, for example, what is the date today? Today it is 20, what's the date? 25, right? Okay, suppose date is 5, okay, 5th of January. So you can write 5th of January as 5/1 and it is 2024, right? You can write that thing also as 0501. Okay, some people write it like this, 0501, okay, 24 or 2024. So in this one you write this thing as 5 or 05, it doesn't matter, right? Yes, no? So that 0 is insignificant. So all zeros before the first non-zero digit are not significant, right? Then there is a rule regarding terminal zeros. Terminal means if you write zeros at the end. So terminal zeros in number without a decimal point, okay, this is important, without a decimal point are not significant, but terminal zeros in a number with decimal point are significant. For example, I say that length of this pen again is 15.70 centimeters, right? So this 0 is significant. Okay, this 0 is significant. Why is it significant? What does it tell you? Why can't I say 15.7 only? Okay, so this is the matter of precision, right? If I say 15.7 centimeter, the reading has been taken with the normal scale, right? Your meter scale, okay, your centimeter scale actually, which you keep in your compass box. Okay, and this reading, it can't be taken using the centimeter scale, right? Here the device used is the vernier caliper. This is more precise instrument. So these trailing zeros, if you have decimal point, these trailing zeros tell you about the precision of the instrument. Okay, these trailing zeros tell you about what? The precision of the instrument. This thing is clear? Yes, no?
Sir.
Yeah, so that's why they are important. That's why they are important. They are significant. Okay, very good. Then now we do various calculations. In 40.00 there will be 4, because these trailing zeros are important, right? And the zeros in between any two significant digits are also important. Yeah, that is before decimal point, but 0 in between two significant digits are also significant, no? Right? Good. Then now we do various calculations. For an example, in this calculation you have two readings, okay? So suppose this is the length and this is the breadth of some rectangle. This is the length and this is the width, okay? And you want to find out the semi perimeter, which is length plus breadth, right? So this is clearly taken with one instrument, this is taken with the another instrument. So when you add it up, you will add it up and you will round it up, you will round up the result to the correct number of significant figures. So significant figures in first one are 4 only, okay? And the precision is up to 2 digits after the decimal point, okay? So here also significant figures are 4 only, that's not the problem, but the precision is different, okay? So precision here is up to 3 digits after the decimal point, so we need to round it off, okay? So first we add up and then we round up. I'm sorry. Okay, so you find out the total and then you will round it off to what? The precision of this instrument, okay? Which instrument? Which is least precise out of the two. If there are 5, you will choose least precise out of the 5, right? What would be the result? It is 18.022. You will round it off to 18.02. Okay, so this thing is clear. So if there is a question like this, so write with correct number of significant figures, then this is what we should do. Okay, everyone? Alright, very good. So now let's see some problems based upon this thing, and this is from NEET 2023. The errors in measurement which arise due to the unpredictable fluctuations in the temperature and voltage supply are which errors? Yeah, very good. It's option D. Very good, Pawarna. Right? Straightforward. Let's see next one. A metal wire has mass. This is also from 2023. Okay, metal wire has mass of 0.4 plus minus this thing, and radius of 0.3 plus minus 0.001 mm, and the length is this much. Maximum possible percentage error in the measurement of density will nearly be. Tell me. What is density? This is a wire, okay? This is a wire. Mass upon volume. It's mass upon volume, right? So density is mass upon volume, and this is a wire. So what will be its volume? It's area of cross section multiplied by length, right? So that is, what is the area of cross section? It is circular one, so this is pi r square. So it is pi r square, okay? R is the radius multiplied by length, and then the error in mass is given, right? Reading of mass is given with plus minus possible error. Reading of the radius is also given, reading of the length is also given. So just use this formula, delta rho by rho will be equal to what? Or we want percentage, no? So let's multiply by 100. It will be equal to delta m divided by m, pi sorry, pi is a constant, plus it is r raised to 2. So let's take 2 times of delta r by r, plus you have delta L by L, and then you will multiply this thing by 100 because you want to find out percentage error. So what is delta M? This is M, this is delta M, right? 0.002 divided by 4. Okay, and let's multiply out with 100. Okay, plus 2 times of delta R by R. So delta R is 0.001 divided by 0.3 plus delta L by L. Okay, this thing also multiplied by 100. Okay, and the last one is plus 5 0.02 divided by 5 multiplied by 100. So tell me what's the answer. Calculate and tell me. Anyone? This 0.2. Okay, this will be 0.2 by 4. Again 0.05, I guess.
0.4, sir. First one.
0.4. This one.
Yes, sir. Denominator.
Denominator means it will be, yeah,
0.4, sir, not 4.
0.
0.4, sir, not 4.
Denominator is 0.4. Okay, denominator is 0.4. Right. Thank you. All right, this is 0.4. So then it will be 0.2 divided by 0.4. That means 2 by 4. So it's 0.5. First one is 0.5. Second one is 0.1. Actually 0.2 by 3. Right. 0.2 divided by 0.3. That means it will be 2 by 3. So this thing will be 0.66. And what about this one? So this thing will be 2 by 5. Right, so 2 by 5 means 0.4. 0.4 plus 0.5 plus 0.6. How much is it? 1.6. Is that the answer? It's option C. Good. So 1.6 is the answer. Right? Everyone can check. Okay, so that's the answer, right? 1.6. Okay, so this is simple question. Yes, no, it is directly based on this formula, composite error, right? Okay, good. Let's see next one. The percentage error in measurement of G is. So this is not from NEET, this is from some other exam, RS 2022. Anyways, so what will be the percentage error? And now they are so generous, they have given the formula also. In NEET it will not be given, okay, mostly. Okay, so you know that T is equal to 2 pi square root of L by G, and from that first you need to find out the formula. Okay, you need to find out G like this, and then you can use these things, right? Okay, so this exam RS, I don't know what, so they are quite generous, they have given the formula directly. Okay, so you can find it out very easily. So G is equal to 4 pi square L divided by T square, and therefore delta G divided by G is equal to what? Delta L divided by L plus 2 times of delta T divided by T. Very simple. Then just put the values. So what's that? Delta L by L. So delta L is 0.1, L is 10. So 0.1 by 10 plus 2 times of delta T by T. So that is 1 by 100. So that is 0.1 by 10 means 0.01. Okay, but you want percentage error, no? So this thing multiplied by 100. Okay, so this thing multiplied by 100. So let's multiply out with 100 everywhere. So this 100 gets cancelled. 100 by 10 is 10. So 10 times 0.1 is 1. 1 plus 2 is 3. So 3% is the answer. Right? Okay, very good. Let's see next one. This is from NEET. The area of a rectangular field in meters square of length 55.3 and breadth 25 after rounding off the value of correct significant digits is. Tell me what will be the area. So length is 55.3 and breadth is 25. So first of all, just multiply and tell me what is the area. Anyone? No, I'm just asking, is it option C? Let's check. I'm just asking what is the area. 1382.5. Okay, good. 1382.5. Yeah. So now round it off first to correct number of significant digits. How many significant digits are there? In in length there are 3. In breadth there are 2. But we want least number of significant digits. Okay, so that is 2. So you need to round it up to 2 digits only. So what will you do? So this is first digit, and second one here itself, what will you do is you will round it up. So see, third one, it's greater than 5. So this digit you will increase by 1. Okay, that's it. So this is 1400, and that point and everything then doesn't matter. 1400, and you can write it as 14 into 10 raised to 2. That's correct. Right, so that is very, very simple. Okay, so these trailing zeros now, they are insignificant. Okay, as we learned, in case of decimal point, trailing zeros will be significant, and here if we write a number like this, trailing zeros are not significant. Right, Selva Kumar?
Yes, sir.
Good. Let's see next one. Taking into account of the significant figures, what is the value of this thing? 9.99 minus 0.0099. Tell me. So you have 9.99 and you need to subtract 0.0099 out of that. Okay, so just round this off. Okay, so it will be minus 0.01, right? So the answer would be 9.98. That's it. Okay, you can carry out the subtraction and round it off, still the answer will be same. Right, so it's option B. Okay, this is also from NEET 2020. So NEET 2020, 2022 significant digits. I'm sorry. And then yeah, 2020, 2022. So these are these questions are designed by NTA, okay, who is currently designing a NEET exam, right? So these are free marks actually. This question you should never leave. These are free marks, right? Let's see next one. The number of significant figures in the numbers, this one and this one. Yeah, tell me. This one and this one. How many significant digits are there? This is very, very simple. It's option B. Yeah, everybody is saying very good. 5 and 7. Good.
5 and 7.
5 and 7. Very good. Okay. So it's option B. Next one. Period of oscillation of a simple pendulum in the experiment is recorded as this thing. The average absolute error is. Tell me. So now this is simplest of all possible questions, right? But this one is lengthy. That is the problem. Okay. So if you are running out of time, then keep this aside. Okay. If it's in the beginning, if you are doing it fast, do this one. This is sure shot, 4 marks, right? So tell me, what will you do first? So these are n measurements. Okay, what do you need to do is find out their mean. So mean time period is equal to 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80, okay, and divided by, you have n is equal to 5, I guess, 1 2 3 4 5, right? So you will find out mean. Okay, then how much is that? 2.63, 42, then 7180, I don't know. You need to add it up and divide by 5. Anyone? $13.12, that's addition. Divide that by 5. 13.72, divide that by 5, no? $2.624, okay? So that is 2.62 with significant digits, 2.62. So what is the error in first one? 0.01, right? And we are taking absolute error now, plus error in second one is 0.06. Error in third one is 0.20, that's too much. Error in next one is 0.09, and error in the last one is 0.18, and you divide that by 5. So this is how you will find out the mean absolute error, but it takes time, right? So 20 plus 18 20 plus this is 27, that is 47, 47 plus 1 is 48, 48 plus 6 is 48 plus 6 is 54, 54 divided by 5, so that is 108. So 0. Okay, that will be 0.1. Okay, 0.108 it is, and you will round it up, so it will be 0.11, not 1, right? So this is the answer. It's option B. No, it's option B, if my calculation is correct. I'm sorry. Sorry. Okay, actually the error should have same resolution as that of the reading. That's the first rule. Okay, so 0.1 doesn't have, 1.0 doesn't have, so it has to be between this one and this one. So my calculation is 0.108, and I am rounding it up to the same significant digits after the decimal point as that of the readings. So that's why it is 0.11. Somebody check whether this thing is correct. Yes, no? Correct? Good. So then this is the answer. Okay, so here also. Now you might be tempted to write this thing, but this is incorrect. Okay, this is incorrect. Why is it incorrect? Because your answer should have same number of significant digits as that of what? As that of the readings. Right? Everyone, this is clear? Okay, good. Let's see next one. If voltage V is this thing and current is this thing, the percentage error in the resistance is. Okay, so what is resistance? It's V by I. Now these are kind of repeated questions. So you have delta R by R multiplied by 100, because you want percentage error. It will be just delta V divided by V multiplied by 100 plus delta I by I multiplied by 100. It's very, very simple, right? So that's 5 by 100 times 100. That's very good. 100 gets cancelled out. Okay, plus 0.2 by 10 into 100, even that is good. So 100 by 10 is 10. 10 times 0.2 is 2. This was 5, that is 2, so 7%. Right, option C. Good, 7%. Very simple. Let's see next one. Okay, you measure two quantities as A equals to this thing, B equals to this thing. We should report the correct value for root AB as. Okay, so there might be question like this. So first of all, find out root AB. So what is A? A is 1.0. What is B? It's 2.0. So what is root AB? So suppose C is equal to root AB. Tell me. Okay, so A is 1.0 and B is 2.0. So multiplication would be what? 2.000, something like that. Am I correct? 2.00, right? But you are taking square root, so it's just square root of 2. So what will be square root of 2? I told you to remember that, 1.414, right? That is square root of 2. But then your reading, I mean your measurements, they had only one significant digit after the decimal point, so you need to round it up. Sorry. Okay, so you should round it up to what? 1.4, right? But that is one part only. And then you have delta C by C, because you are multiplying. Okay, this is equal to, C is equal to what? It's AB raised to half square root, right? So it will be equal to half of delta A by A plus half of delta B by B. So that is equal to, tell me, what is delta A? 0.2. So it's half of 0.2 divided by 1 plus half of 0.2. Okay, half I have taken out, 0.2 divided by 2. So what's that? 0.2 by 1. So it's like 1 divided by 0.2 is 5, right? So 1 by 5. Sorry, 1 divided by 0.2 is what? It's 5. Yeah, so it is 1 by 5. So that is 0.2 only. Oh, what I am. This is 0.2. All right, 0.2 by 2 is what? This thing is 0.1 only. Okay, so this is 0.2 plus 0.1 is 0.3. So 1 by 2 times 0.3. Okay, and then you have delta C.
100, right?
No, that you will do when you want to find out the percentage error. Here
Oh,
you are
okay.
just finding out the relative error.
Okay, sir.
Right, take C on that side. So C is 1.4. So this thing multiplied by, delta C is equal to, take C on that side, so 1.4. So this thing is 1 by 2 of this, this will be 0.15 multiplied by 1 by 1.4, or better way, it's 0.7 multiplied by 0.3. How much is it? 0.27, right? Okay, and still it rounds off to what? 0.3. Yeah, so it is, no, it is 0.27, no? So it will be 0.3, round off, right? So answer would be 1.4 plus minus 0.3. Okay, so it's option C, not D. Right, everyone? This is simple. Yes, no? But there is some process involved in this one. Right. Which number to round up to? But that is very simple, no? See how many digits are there in your reading. Okay, here there is one digit after the decimal point, so you need to round off to one digit after the decimal point. That's it.
Sir,
Yeah, tell me.
the delta C is equal to half into 0.3 into 1.4, no, sir?
Delta C is
Half into 0.3 into 1.4, sir.
right.
If we cancel out with 2 means 0.7, sir.
Yeah, 0.7.
Then it will become
Okay,
2.1, no, sir.
right. My mistake. Sorry. It will be 0.21 and this will be 0.2. Okay, very good. Sorry, my mistake. I multiplied 9 with 3. I don't know from where. Okay, then it is 0.02 and then it is what? Option D. So Poorna was correct. Alright, I can do that. You should not. Right? I don't have to write an exam. Alright. But is the process clear, everyone? Okay, good. Let's see next one. In an experiment, the percentage of error occurred in measurements of physical quantities A, B, C and D are this thing 1%, 2%, 3% and 4% respectively. Then the maximum percentage error in the measurement of X, where X is equal to this thing, will be, tell me.
16%, sir.
Is it 16%? Right. Let's see. Delta X by X would be what? 2 times of delta A by A plus, even writing this is not worth, right? We'll just calculate it. Okay, half of delta B by B plus 1/3 of delta C by C plus 3 times of delta D by D, that is equal to 2 times of 1% plus half of 2% plus 1/3 of, okay, that's very good. They have given the values that get cancelled out, plus 3 times of delta D by D is 4%. So this is 2 plus 1 plus 1 plus 12. Yeah, so that is 16%. Okay, so answer is 16%. Right, that's very simple. Option C. Okay, good. Let's see next one. The density of a cube is measured by measuring its mass and length of its sides. If the maximum error in measurement of mass and length are 3% and 2% respectively, maximum error in the measurement of density would be. That is very simple. Density is mass upon volume, and volume of a cube is just L raised to 3. Right? So delta rho by rho would be equal to what? And here you want percentage, so multiply by 100. Okay, it's 9. Let's check. So it's equal to delta m by m plus 3 times of delta L by L. Okay, so delta m is 3%. Yeah, this thing multiplied by 100. This thing times 100. This thing times 100. Delta m by m times 100 is 3% plus this is 3 times of 2%. So that is just 3 plus 6, 9%. That's correct. Very good. Okay, it's very, very simple. Okay, let's see this one. All right, good. So first of all, if there is a question like this, get happy. Right? In an experiment, 4 quantities A, B, C and D are measured with percentage error 1%, 2%, 3% and 4%. The quantity P is calculated as follows. The percentage error in P is, tell me. Three times of 1%, 2 times of 2%. Option C, everyone? Good. So it's option C. All right. So then there are similar kind of questions. Okay. And there are one or two good questions also. So I will just leave these questions for you. Okay, as a homework, and there will be added homework also. Okay. All right. So then there are some questions. So these questions, no, where you have bold face marking. Okay. So there are 3 questions, I guess, with bold face marking. So if possible, just send me the solution of this. Okay. All right. Others, you can try. They will be simple.